Bismillahirrahmanirrahim. How to solve a series circuit. In this tutorial, I am going to show you how to solve series circuit. How to solve series circuits with the help of Ohm's law. I will explain with the help of different circuits with equal resistance value and different resistance value, and in the end with the help of multi-sim live simulation. This is the first method of solving a series circuit with the help of Ohm's law. V is equal to IR and RT is the total resistance in the series circuit. RT is equal to R1 plus R2 plus RT up to nth resistor. This is the second method and we will discuss in the next video. Now this is the first circuit I am going to discuss about this circuit. It has a voltage source and two resistors are connected in series and both have a value of 1 kilo ohm. What step should I follow to evaluate voltage across them? First of all, evaluate current flowing through the circuit. Then apply Ohm's law to individual components. Now, as you know, V is equal to I R1 plus R2. You should keep in mind current remains the same in series circuit. So the current flowing through R1 is equal to current flowing through R2 and it is 5 milliampere in here. Now for voltage across R1 and R2, apply Ohm's law to individual resistors. As you know, potential difference or voltage is measured between 2 points. So to measure voltage between across R1, we measure voltage in between these 2 points. V1 is equal to I R1 since R1 is equal to R2, that is both resistance are of equal value. In this case, both resistors have same voltage drop. This is V2 is equal to I R2. We have calculate circuit parameters, that is I is equal to 5 milliampere, V1 is equal to 5 volt and V2 is also equal to 5 volt. Now come to the next circuit. Here again there is a voltage source of 10 volts. R1 is equal to 1 kilo ohm and R2 is now 500 ohm. Now first of all, we need to evaluate the current flowing through the circuit. In series circuit, current remains the same. Let's calculate the value of current. Again the same formula, V is equal to IR and I is equal to V upon R1 plus R2 and I is going to be 6.6 milliampere here. Now calculate the voltage across R1 and R2 in the same manner. V1 is the potential across R1. In these 2 points, V1 is calculated between these 2 points. Similarly, V2 is equal to IR2. We have analyzed or calculated the circuit parameters, and V2 is equal to 3.3 volts and V1 is 6.6 volts. That's it. As you know, the voltage across higher resistor is higher and the voltage across the lower resistance is lower. Now come to the next circuit. This is the third circuit we are going to analyze. Here 3 resistors are in series and all of them are of equal value, so voltage drop across them is also same. Again, the same method of calculating voltages across resistors. This is V1, voltage across R1. This is V2, voltage across R2, and this is V3, voltage across R3. I will discuss in the end how to measure these values in multisim live. V1 is equal to V2 is equal to V3 and all of them are equal to 3.3 volts. Now come to the last circuit. Here again there are 3 resistors but all of them are different value. First resistor is 100 ohm, R2 is equal to 200 ohm and R3 is 700 ohm. Calculate the current. I is equal to V upon RT and RT is equal to R1 plus R2 plus R3, that is the total resistance of series circuit. This is V1, V2 and V3. Again the same method of calculating voltages across these resistors, and I comes out 10 milliampere. Now V1 is equal to 1 volt, V2 is equal to 2 volt and V3 is equal to 7 volt. Please correct it, V3 is equal to 7 volt. V3 is 7 volt. Now this is multisim live and I am going to show you how to measure voltage across the resistor. Place probes across each, place negative probe as well. Similarly, place the third probe. Here you don't need to add the negative or reference probe because voltage is always calculated with reference to ground, so no need to place reference probe for VR3, but I add because of better understanding. Now this is all about. Thanks for watching. Goodbye for now.